Hi there, guys. Nathan B. Here, back with part two video on locking down your Vulcan node and how to secure your node in a better way. Now, straight out of the gate here, a disclaimer is this is complicated, these steps. It will cost money to implement these steps. It's $18 a month for Azure, and in AWS to create this load balancer it is around the same. Um, the second or the third disclaimer here is that none of these steps have been approved by the dev team or the core team of Vulcan. I want to just get this up now so we can, you know, um, look at it and understand it and, pull it back up when we need to. But now, in saying that, it's the problem here is all of our nodes, or at least the 500 full nodes, they are going to be um, so far, from what I see so far in testnet, that they have this public IP that is directly attached to the virtual machine, whether it be AWS, whether it be Azure, maybe the other ones are the same. So that goes against all security best practices around running cloud infrastructure, being a compute virtual machine. That just exposes that resource to the internet. Okay, and there's a lot of these guys out there that search for public IP addresses and then start hammering them to try and get in. Okay, and what they do is they get a list of services protocols that are common to the world, like 22, and then they just continually try and get in. And again, it's like, okay, well, we have the PEM file, we have the PPK file, but you really don't want the cloud service, Azure or AWS, to see all this traffic and potentially, I don't know, they may stop that by stopping access to the box or try and stop it for you, or um, and there could be downtime there, right? But if you take a step back, as I said, really just the bottom line here is that having a compute node with a public IP address directly attached to it is just not a good idea. And so this video goes through on how to rectify that. Um, so it is, unfortunately, I think, going to be long. So grab a coffee, grab a triple espresso, and let's go through this together. Okay, guys, let's get started here. There's going to be a few steps here. I'm probably going to try and take this slow because, as I said in the intro, it is complicated. Now, the first thing what I want you to do is to test whether we can connect to our Vulcan node. So if you go to your virtual machines again, click on your actual virtual machine, go down to the networking option here, and click on SSH. And if you follow the previous part one, you should have your home or business public IP address in there. Okay, so make sure that. I'm just going to minimize this, and if you don't remember, this is the URL here. What is my IP? And that should give you this public IP address. That is not mine. That is just a simulated one, but that's where I'm connecting from right now. Okay, I'm going to go back to my command prompt just to make sure it connects. My USB stick, I'm going to plug that in. Okay. Okay. Connect to my node. it works. So I know that baseline is I can connect in the current configuration. Okay, I'm gonna leave the USB stick in at this point, and I'm gonna go back here. All right, so there's 3 inbound ports here. Remember, there's 8545, 30303, and 22. I'm going to start with 22 with creating this load balancer and rules. Um, and then I'm going to actually go and remove the network card attached to the Vulcan node. Okay, so first step is you may have over in the left hand side this resource called a load balancer. If not, you can just search for it up here. Um, Type it in and click on load balancer. This is the thing that will cost you $18 a month. Okay, so the option over here is going to be this one. That one, load balancer is the service that should be selected. You want to click on create. Okay, now in the subscription, my subscription is called Vulcan. Yours may be called Azure Subscription 1 or something if you renamed it. Create it in the same resource group as where your node is to keep it all together. I'm going to give it a name here, ELB dash, ELD dash, maybe just that, ELB, because it's just a elastic load balancer. And I'm going to select the US East. Standard is the one that costs $18, but that gives me the features I need. So I'm going to leave it on that. I don't think Basic allows us, which is free, which allows us to achieve the routing that we need. So the type here is going to be public in a public facing, and regional is fine for this. I'm going to click on next down the bottom where it says front-end IP configuration. Okay, I want you to click on add a front-end IP configuration. Now for the name here, I'm going to type in ELB front. Okay, IPv4 is fine. IP address is also good. Um, Under here, I'm going to create a new actual public IP address resource, and I'm going to do ELB again, and I'm going to add this as pub IP. Okay, maybe I've already got one, so I'll just call it PIP. The naming doesn't matter here at all. Standard, it's all standard SKU static. Make sure that you have static there. I can't change this because of the standard SKU, but static is what we want. I'm going to click on no zone redundancy for now. I'll update the description if I find that that's a better fit, but for now we're just going to, where we are now, we're just going to select no redundancy, no zone. I'm going to click on OK, no gateway load balancer, and I'm going to click OK. At this point, I'm just going to click on review, and create. So I'm going to create the resource, and then I'm going to fill in all the other tables later on. Okay, there we go. So there is my ELB resource. I'm going to click on that, and I'm going to give myself some real estate here. Okay, if I look at under the settings here, I'm going to go from top to bottom. The front-end IP, there should be a front-end IP because I created a resource ELB front, and it's now created a new IP address for me, which you can see here. Okay, a new static IP address that's attached to the front end of that load balancer resource. I'm going to take a note of that actually. I'm just going to go and copy that, and I'm going to put it in my notes here. for later on. Okay, I want to then go down to backend pools, and we're going to create a backend pool. Okay, you just need to give it a name. I'm going to go with the same back, see if that works. And then under virtual network, there should only be one, which is going to be the virtual network for your node, where your node, the virtual network that your node is using. So just select that one. Leave it as network card here, and then click add. And hopefully you'll also see the machine name of your VPS or your VM, your Vulcan node here, and you're just going to select that for the backend pool. So it's going to point to this IP address. Click on add, and then click on save for that. If yours is a little different with the resources names, that's fine. It doesn't have to be the same as mine. It has to be the same as what yours is. Okay, now we are back. I'm going to do the third option here, with is a health probe. Click on add, ELB-health. Okay. TCP, this time I'm going to select 22 for the SSH port. Okay, so then we're going to click add. Okay, now I'm going to skip this load balancing rules, and I'm going to go down to this section here, which is, so we have done these three here, and now I'm going to do this last one here, which is the inbound NAT rules. So click on inbound NAT rules, and then click on add. Okay, this is just a name, ELB NAT. I'm going to select it Azure Virtual Machine because I want a NAT, which is network address translate through to my virtual machine. Target virtual machine is going to be the Vulcan node. Yours should have, or possibly has, a different name to that. Network configuration, this should be a drop down, and it should be the only one that's there unless you have a subscription with a lot of resources. I doubt it, but that's just going to be that. And then the front end here is going to be that ELB front that we created, which is that IP address. And now you can start to see that that IP front end is going to talk to the virtual machine 10.0.0.4 in my case. Okay, now the front end port here is saying what should the network load balancer be listening on, what port on the internet. Okay, and I'm going to give it, I'm going to try a 1, 2, 3, 4, 5, 6. Okay, so I'm going to just try 4 here. 1, 2, 3, 4. But it can be anything. This here can be, 0 to 8, 9. It can be any random 4 digits, and it should be something that you know. And you don't have to remember it because you can save it inside a file. But yeah, I'm just going to use 1, 2, 3, 4 here. But I wouldn't be using 1, 2, 3, 4 in a mainnet deployment. I would be using something else. The service tag we're going to leave as custom, and then, okay, I'll try that again. 1, 2, 3, 1, 2, 3, 4, yeah, and then I'm going to leave that as custom. And then the backend port is going to be 22. TCP is selected, everything else is fine. I'm going to click add there for my NAT rule. And wait for this to save. Yeah, so essentially what I've done is I've created that front-end load balancer with a brand new public IP address, and then I've created rules that say if anything asks this public IP address on SSH22 with a port coming from a port 123, specifying a port 1234, the load balancer is going to take that and push it to the Vulcan node internally on 10.0.0.4, and it's going to translate it to 22. Okay, that's what we've just done now, and let's see if let's see if this works. Okay, now what I'm going to do is my USB is in there, so it's pointing to that. I'm now not going to connect to this that's attached to my virtual machine. I'm going to connect to the load balancer. Okay, I'm going to delete that, and I'm going to add the load balancer front-end IP, and then I'm going to specify a P for port, and I'm going to do 1, 2, 3, 4. Okay, and let's see if now that load balancer answers me on 1, 2, 3, 4, and then it then routes it to my Vulcan node to 22, or it translates it. Okay, that's fine because it's new, so I'm going to type yes here, and it connects. All right, so it works. I'm going to exit that now, clear the screen, and so now if I then try and connect via this, it will still work, right? Because I still have that Vulcan node that has the public IP address attached. So it still should work. That's expected. But we want to do another step eventually to make that not work, and we'll come back to that. All right, now let's go back to the portal itself. All right, and I'm going to go here. Well, we're actually at where we want to be. So I am going to go and create another NAT rule here. Okay, ELB, and this time I'm going to call this one NAT 30303. Okay, same thing, Azure Virtual Machine. Target machine is going to be your Vulcan node. The private IP address of the node, this is not going to change. Now this time I'm going to do, I did 1, 2, 3, 4 last time. I'm going to do 4, 3, 2, 1. No, I'm sorry. This time what I've got to do is I've actually got to do 30303. And let me just do this as well, 30303. The reason for this is because right now there is no way that the Vulcan blockchain software can come and ask on 4321 and then us translate it down to 30303. Potentially that might be something that we could look at changing, and I'll ask that, but right now this is the best way to secure this, is to just from the load balancer itself, it block everything coming in. We remove the public IP address from the node, and then we allow 30303 to come straight through the load balancer. The same with 8545, but 22 we lock down like we did before. So let's click on add there. Okay, and we're just going to do the same on 8545. All right, let's click on add here, and we're going to do the last one, ELB net 8545. Same here, target virtual machine is going to be your node, all the same down. This time it's going to be 8545 custom, and then backend is going to be the same thing, 8545. Okay, add there. All right, I have three three rules here. One for 22, the first one there. This second one is at 30303 and 8545, and you can see the only one that has changed here with the front end, what is being asked is the SSH. These two are the same because of that dependency from talking to other nodes, etc. All right, the last step in the load balancer is to create a couple more health probes here. So we're going to create a ELB for 8545, 8545, create that. And then I'm going to create a second one here, ELB 30303, 30303. Add that one as well. Okay, now that is done. All right, now if I go back to my virtual machine and I click on my virtual machine, I go down to networking. I still have this source lock here at the virtual machine level. This will still work fine, and so we won't be touching that at all. Now the last thing I want to do, at least in Azure, is you want to click on this here, which is the NIC public IP address. Click on that, and then you want to disassociate. Okay. Yep, I want to remove that. Okay, you can see now that there is no public IP address attached to this Vulcan node, and you can see that the private is still there, 10.0.0.4, but that's not exposed to the internet, and everything else is the same. Okay, so what I want to do now is I want to test and see at least if I can SSH to the machine. So let's try that first. Okay, my USB stick is still in there, and I am connecting over SSH to the to the load balancer, which was 20.231.16.77, specifying port 1234. That works as expected. We tested that before. Now the big test here is, can anyone get in on this old IP address that was attached to the virtual machine? And that's going to be pretty obvious. And you can see it failed there, okay? And that is to be expected. I could even try things like, okay, well, maybe it works over 1, 2, 3, 4. That's going to fail as well. I don't need to try 22 because by default we're using that anyway. So this is going to fail. It's going to time out. It would have already succeeded. And I want to go back to the portal here. Yeah, I mean, so in summary, we've created this load balancer with some rules in it that allow us to take away that public IP address from the node and create um, these NAT rules, NAT rules that allow us to have, this is now the public facing IP, um, and kind of hiding port 22 at least to the node itself. And I'm the only one now that can, with that PEM key and with the 1234, really get through to that node. And you should be able to now just give this as your public IP address to the team to set this up for the testnet node. So it'd be interesting to see if really someone wants to try this out, um, and deploy this and then see if we can add it to the testnet legitimately to make sure the entire solution works. But yeah, leave me some comments, some questions. I might revise this once we test it further. But as I said at the intro, this hasn't been approved. It is a way to do what I said, to remove that vulnerability of having the public IP address attached to the VM. But let's just continue on this journey of trying to secure these nodes in the best way we can. So until the next video, bye for now.